let me start with the set. So, the screen visible to everyone? Yes, no, maybe. So, set we have three classes. I hope my screen is visible. Yes, anyone? Can anyone confirm? We have three classes in the set, and set, as we had discussed, will not allow duplicates and will not preserve the order of insertion, right? The order of insertion and will allow only single null value. Will allow only single null value because duplicates are not allowed. Okay. Okay. So this stands for hash set. This stands for hash set. Okay. Wherever you will see the linked keyword in the collection classes, wherever you will see the linked keyword, always remember order is maintained. This is the cheat code. So wherever you will see linked means order is maintained. So if I want the remaining two features, but along with that I want to preserve the order of insertion, then I go with, so linked hash set will do what? Yeah, like a like list, right? Yeah, like list. So if you don't want duplicates, but you want the order of insertion to be preserved, like list, you go with linked hash set. Okay, and in tree set, the order is ascending order. Okay, will add in ascending order. So we preserve the order, will add in ascending order. So whatever elements you will add, you will see them that they've been added in the ascending order in the tree set. So this is the primary difference between these three: hash set, linked hash set, and tree set. Okay, and in tree set it will compare and add. What it will it do? It will do what? Will compare and add, like binary search tree. So if it is small, goes towards the left. If it is right, goes towards. If it is greater, it goes towards the right. Okay. Yeah. So let's do some practical of this. Let me start up my Eclipse and show you all something. So we can use the set, as the name suggests, with regards to our mathematical set, or in any situation where you don't want the duplicate. So if I have set A and if I have set B, and I want to find the union and intersection of those sets, remember? So in such regards, we can use a set. So if I have set A and if I have set B, so if I have over here in A 1, 2, 3, 4, 5 are there in both, and 6, 7, 8. Okay. So what does set A contain? 1, 2, 3, 4, 5, right? So we were with you guys over here. So we were in the collections for you guys, right? So in the collection, let's make a class HashSet demo. So I do a set of integer. Okay. I call it set A is new hash set. Then to set A, I add what? 1, 2, 3, 4, 5. Or directly I can do it over here. Arrays dot as list 1, 2, 3, 4, 5. Okay. So if I display this set, will it show me the in the order which I added them, or will it show me in any random order? Uh, yeah. So output, if you will see, will show me in any random order. It's doing some processing over here. Let it complete the process. It's showing a red dot over here. Means what did I miss out? I've done that. Okay. So let's make one more set also. Meanwhile, it prints the output for me. 3, okay, 4, 5, 6, 7, 8. So if I go and display the set B, it should display me the sets. Okay. Now if I want a union of the sets, what I want, so union. So what is union? A union B will be what? 1, 2, 3 without duplication. Yeah. So how do I get this? Any idea? So I will take, okay. So what I will do is set A dot add all. Remember, of set B. So what happens over here? So all means 4, 5, 6, 7, 8 also gets added, right? But set doesn't have duplicate. So what will it add only? So A will have 1, 2, 3, 4, 5, 6, 7, 8, right? Yeah. So if I display now, if I display A union B set A. So what should this display me? 1, 1, 2, 3, 4, 5, 6, 7, 8. Correct? Okay. Okay. Now let's say I want the intersection. Then if I want the intersection, okay, this some error it is showing me. I don't know why. Where? At times when everything is good, it still tries to system dot order plus, and I've given a bracket open for that. Let's run it again. What happened? It's again showing the same error. Line number 14. I have given the wrong bracket. So why is it showing that? Strange. I've done the save. Okay, I'll remove this line. See, I remove the line. Still it shows me an error now. I remove this line also. Still the error. Okay, now there is no B, so I understand there is no. Okay, error has gone. I copy this. I paste it. 4, 5, 6, 7, 8. I call it as set B, and I display B. And then what do I do? Set A dot add all of set B. Yes, so nothing. I did not change any code. The same thing. Okay. A is 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, and union is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. So let's try to do the in intersection then. So I take one more element. Okay. So I have not done the union now. Okay. Let's say I have not done the union. So what does A contain? What does B contain? 1, 2, 3, 4, 5. B contains 4, 5, 6, 7, 8. Now what is intersection? So if I say set A, and if I do set A, retain all of set B, means whatever is in set B, only retain all of them in set A. So of set B, what does set A contain? So only those will be there. Rest all will be removed, right? So let's try to do a set B dot set A dot retain all of set B. So now what will set A have now only? It will have only 4 and 5. So A intersection B will have only 4 and 5. Make sense? Okay. So in the hash set, the elements are inserted with their hash code. How they are inserted in the order of their hash code. If for integer, the integer value itself is the hash code. So what is the hash code for 1? What is the hash code for 2? So if I have integer, okay, I1 is new integer, and it is a hash code is a function, right? Of the which class? Hash code is a function of which class? Object class. Object class. Object class. So now I have how many integer objects? 1, 2, 3. So if I want to check the hash code for this, so how will I check that? Now, okay, hash code of I1. What is I1? I1 1 is, so how do I check the hash code of that? Is I1 dot hash. Okay. So what will be the hash code of 1? Hash code of 1 will be 1. Hash code of 2 will be, and hash code of 3 will be 3. So whatever is the integer value, the hash code value also is the same. So let's prove that. So that's why you will observe that they have inserted them in ascending order because it arranges them in the hat. Getting it? But this is not always the case for strings. So if you will use string, okay. So if I have string name1 is equal to Alice, okay, and Alice Ben Chris. I have three strings, and now if I want to see their hash code, so will be some integer value. Hash code of name1 is name1 dot hash code. Okay, hash code, not hash. There should be an H over here. Similarly over here also. H hash code. So name two, name three, name two, name three. Let's check this out. Got it? The hash codes. Okay. If I would have prepared these strings using string object, let's see, would there be a difference in the hash code? 1, 1, 2, 2, 3, 3 is new string, is new string, is new string. And now let's check of name 1, 1, name 2, 2, name 3, 3 is name 1, 1, name 2, 2, and name 3, 3. Let's see if there's any change in the hash. What happened? 3, 2, 3, 3. Okay. Okay. ठीक है. Let's check now. See, 6, 3, 3, 5, 0, 3, 6, 8, 6, 6, 6, 6. Okay. So the string will have a hash code. Irrespective, you make it using the string literal or using the string class object, it will have its hash code. Let's say if I have an array of characters, okay, so we have a character array and I give over there a, l, And then I want to check the hash code of this array. Then it should be something different. Hash code of now let's check. So see the array it becomes different. So it's an array now, right? And using this array, if I convert it into a string, then the array, if I have made it into a, now let's check, has the same one now, right? Again, 633 5036. So internally, what happens is every object, the hash code is calculated, and then the objects are inserted in the collection with regards to their hash code. Okay. So there's some calculation done on the hash code, and then based on that calculation, they are inserted. So why is it showing me always in inserted order over here? Because the hash code of integer also is the same. Okay, that's why. So if it calculates the hash code and inserts them in the order of the hash code, so as the order of these integers are same, this is inserting me like this. Okay. So if I try to display now, if I try to add these three strings to a collection, okay. So if I take this HashSet demo, I copy and paste it. Okay, HashSet demo 2, and I just keep these strings, and I want to now add them to a hash set. So set of string is new hash set. Set of string set 1 is new hash set. Okay, and now to set 1 we add them, name 1, name 2, name 2. Okay? You can add them individually also, or you could have added them at once also, like this. Hash set 2 is new hash set, arrays dot has list, and whatever you want to do. Arrays then this. And now if I try to display both of them, sys out set 1 and sys out set 2, I am not sure will the order be preserved or not. I am not sure about the order preservation or not. Alice Chris Ben, Alice Chris Ben. See, okay, it has not preserved the order. So let's add some more elements to the set 1. David, Tom, Frank. And let's add them over here also. David, Tom, and Frank. Okay. So see, in any order it is showing me. It is not maintaining the order of the insertion. Correct. Hmm. So now if I want that this order should be maintained, what to do? Convert this into a linked hash. Convert this into a linked hash. So linked hash set will always guarantee the order of insertion. So now if you will display the set 1, it will always preserve the order. So I have names set 1 added all this stuff, and set 2. Where did the display part go? So convert this into a linked hash. Okay. So view doesn't matter much. Okay. Now let's check. So the linked hash 1 set 1 will always preserve the order. Set 2 will not preserve the order. See. See set 1, Alice, Ben, Chris, David, Tom, Frank. The order in which I inserted, it is giving me in that order only. But here the order is random. Okay. If you want them in the ascending order, then Alice, Ben, Chris, David, Frank, Tom, then make it into a tree set. Okay, so I'll keep the options open for both of all of these. So I'll make a tree set also over here. So tree set. That will be my set. Let's say set 3. So set 3 is the tree set. So if you'll observe, tree set will always compare and insert. What will it do? Compare and insert. So the first element will be what in the tree set? First element Alice. So Alice will become the root. Alice will become the so Alice will become the root. Let's say the next element is Ben. So Ben B is greater than Alice. Ben goes over here. Okay. Next element is so Chris is greater than Alice. Chris goes over here. Next is okay. Let's give some proper. Let's give some proper data so that January, February, March, April, May, June. April, May, June. Let's say okay. I should have given that over here then. April, May, June should have come over here. Rather, right? April, May, June. Yeah. So now tell me who goes first? Name 1, name 2, name 3 is Jan, Feb, March, right? So Jan becomes the root. Let's write all this in the comment. Then comes Feb. Feb will come where J and F is smaller, so will come towards the left side. Then Jan, Feb, March is greater. Then March will come here. April, left of February. May, MAR, MAY, Y is greater than that. Okay, June, JA greater, but less so will come here, right? So like this, it will store the data in a binary search tree set. And when I fetch the data, I will go to the ascending order. So we'll take Jan, Feb, April, then June, March, and May. Okay, we go to the tree set. So this out in set 3. So it will see the order of insertion will be ascending order. Okay, April, Feb, Jan, June, May, March, May. Okay. Now this tree set always compares and it places, right? So now next, if I have July, what will it do? First, compare July with Jan. So JA and JU, what it is, greater or smaller? Jan is greater. Wow, very good. U is greater, right? Yeah. So July will come towards the right. March and July will go towards the left. June and July, so will go towards the left of June, right? July will come here. Yes or no? You can shift this towards the right. Make sure it looks better like this. Right, correct? So every moment it is comparing and placing, right? Okay, if instead of now we know that collections can be used in heterogeneous matter, correct? So if I would have wanted, I could have done this also, right? So this would give me the luxury of adding any element. So I could have added over here 100 also, because now my collection is heterogeneous. But what would happen now is it would compare 100 with what first? Compare 100 with the root. What is at the root? Okay, so all these got added, no? Jan, Feb, March, April, May, June got added. Now I'm adding 100. So how will it compare 100 with first what? Jan. So what is greater? You can compare apples with apples and oranges with oranges. You cannot compare apples with oranges, right? Can you compare apples with oranges? No. So that's why this, okay, so it will not allow me. So tree set is the collection which needs homogeneous data. So wherever you will see tree set, always remember wherever you see the tree keyword, always remember that this data is homogeneous. This cannot be, even though it is a collection, but it is always be in homogeneous manner. Why homogeneous? Because it compares, and you compare apple with apple, oranges with oranges, right? So now this will not allow me. See, when I save this and I try to run this code, this will throw me an exception. This will throw me, okay, got it? And it is telling class cast exception. I cannot cast java.lang integer because I want to compare it with a string, right? So cannot be done because I need to compare this with Jan and I cannot compare it. So it is throwing me an exception. So whenever you are playing with tree collections, always remember tree collections will always be, yes, always be homogeneous. Okay, so yes. Now let's try to act smart and let's now try to do this 100. Now, now let's check. So it adds all the numbers in the front. Okay, it adds all whatever numbers will come will be added to the front. So let's check what is the ASCII value of 100. Interesting, right? The hash code, sorry. Let's check the hash code of 100. The hash code of 100 is 48625. Okay, so the 100, the integer hash code 100. Okay, now can I check this? So let's check how good you all are. So what will be the hash code of 100 then? Only 100 dot hash code. Yes, only 100, right? Will it show? So if I write over here 100 dot hash code, it will display me 100, right? Who all say no? 100 is a primitive. Primitive will not allow many functions calling. So you will have to convert into a new into a non-primitive. Non Now from here you have to call the hash code. So now we have a 100 hash code is 100. Getting it? You cannot call methods on primitives. No? You have to always use non-primitives to call the function. Okay. So got the difference between uh, your hash set, linked hash set, and tree set. So tree set always needs data in same manner because you have to compare and place it. Okay. Now if I have a student class, right, and we have some objects of the student class. Now we have some objects of the student class. So let's say of the student class, I have three objects. Student S1 is new student. And what are the parameters? I guess it is roll number, name, and percentage. Okay, makes sense. Now I have one student object. I have two student objects, three student objects. Let's say. So the argument says we'll take only three. Okay, so we have 18. Let's say I take one. Okay, I'll take 25. So I take 14 as Alice and make it 88.5. And I take one as Tom and I give it as 87.5. Okay. Now I have three objects. Now I make a set of what? Students, right? Students. Now I want to make a students and I want their role attendance. How do the teacher take attendance? Do they take it via roll number or via name or via percentage? So students attendance list. What I want? Okay, attendance. I want attendance. Attendance. So when I say new tree set, okay, because it is sorted by attendance, right? So, and now in this student's attendance, I will try to add what S1, right? So now who comes at the root? Who comes at the root? It's a tree, right? It is at the root. Correct? Making sense to you all? Then when I say next S2, so which record am I trying to add? Which which record I'm trying to add? Alice, right? So I'm trying to add 14, 14, Alice, and 88.5. Now where will this record go? Left or right? Because list will always compare and place, right? So on, so where should I put this Alice? Towards the left of Virat or towards the right of Virat? I'll just plug in my laptop for charging, guys. You'll think of it meanwhile. So you will need some comparison mechanism to compare, right? Because now if I add S2, it will fail and so will throw an exception that I cannot compare the objects. When I run it will fail. See what it is telling. I cannot compare. What it is telling? There is nothing to compare them. So should I compare them based on their roll number, compare them based on their name, compare them based on their percentage? I don't know. So then we have to go to the class whose tree set we have made, or which class. So and we have to tell the student class that I will, whenever there will be a reason to compare. So how do I compare your object? So you will say implement comparable. What you will say? It's the interface in the java.lang package. Okay, and you'll be comparing objects of which class? So this replace this T with student. So now whenever you implement the interface, what you have to do? It has only one method, compare. It has only one method. Which method? Compare to. Okay. So here now we will, now here you can give the comparison mechanism on which basis you want to compare the object. So we are making a list of what? For attendance. Attendance will compare on roll number. So we will say if this dot roll number is greater than S1 dot roll number. Okay, S1 parameter I have given over here. Then I will return one. I will return what? I wanted ascending order. Else if this dot roll number is less than S1 dot roll number, I will return -1. No. If they are same, I'll return 0. So now whenever the two objects will be needing for comparison, now in the here now when I will add the S2, we'll need some comparison mechanism, correct? So it will go to the class which objects these are. These are objects of the student class. We'll go to the student class, okay, and we'll check have we implemented any comparison mechanism? Yes, right? माइक बंद कर लो भाई जिसका खुला है. So we have given some comparable mechanism, and then this is the method which is going to give the comparison logic. So it says whenever you are comparing two objects of the student class, you compare it based on this logic, on the roll number logic. So now when I come here, so now how will it compare now? 14 with 18, what it is? Less. So we'll come over here, okay, and then when I add S3, then will it compare this object? We'll take this object. Now I'm going to add this object to the tree, right? So what will it compare? 1 with 18, what it is? Lesser. Then we will come towards the left. Compare 1 with 14 lesser, so will come towards the left. So like this. Okay, so if I had one more student, okay, whatever his name was, roll number 17, Rishabh, okay, 75.5. Now where would Rishabh go to now? S4, so it would come here, right? First, 17 with 18, lesser, greater, lesser. 17 with Alice, greater. So we'll come over here, right? So if I add this student also, and now when I display the students attendance, it will be what? One, Tom, Alice, Rishabh, Virat. Correct? See, Tom, Alice, Rishabh, and Virat. Okay? Okay. How do they arrange you all in your examination hall, seating arrangement for examination hall? Name wise, right? I guess. So if there are two brothers, so Sheikh will all sit together, correct? Even though their roll numbers are different, but all the Sheikhs they sit one after the other. This is how we would sit. So now if I want to make a new list and I want to arrange them in their exam seat number, okay, in the examination hall. Students, exams marking I want to do. Exam hall. So how will they be sitting? First Alice, these are the names, right? Alice, then who? Then after Alice, we will have Rishabh, then Tom, then Virat, correct? So now I'll have to go and change the comparison logic over here, correct? I have to go and change the comparison. So I have to over the method which I override over here. I'll comment this and I'll freshly override again because as you implement a class, you have to else you become abstract class, right? So I come here and I say, okay, I want to implement it now, but right now I want to compare based on their name. So now I give a new implementation. So then we have a in the string we have a function called compare. Okay, so this dot get s name. We are in the same class, right? So same class member can directly access private data. So don't need to use get also. Directly we can use s name. Dot compare. Getting it? Compare to. So which string are we comparing with? And whatever it does, we return that. So if the strings are same, it returns a zero. If the first string is greater, it returns plus one, right? And s1 dot s name, no, because s1 also has. So now the comparison is based on the name, but as this function is only written once, you will observe even now these will be compared by names, correct? The attendance will now also be compared by names, correct? Because I changed the logic. So this one ideally should have been compared by roll number, but now they'll be compared by because we changed the logic. I wanted to compare the name for this exam hall sitting, but now even they will be compared by name. So both the output will be the same, right? So this output which was there, Tom, Alice, Rishabh, Virat, now will be sorted by name and both the output will be same, right? Got it? Yes or no? Okay. Then I want the toppers list. Those students who are, I want to give them rank 1, 2, 3, 4. So now I will compare by percentage. So I come here now, student rank, student rank, student rank, student rank. So for this, I want to compare by percentage. So I come over here and I say I don't want by name also. I want to compare by percentage. So we'll copy this logic and we'll just change the, okay, we'll just copy this and we'll just change the dot, dot per, right? And as it is in the same class, we can use the direct, we can use the private data. What is the object name? S1 I'm giving, okay? So here just change to per. But this will arrange in ascending order, right? This will arrange in ascending order. I wanted descending order. So I change the order of -1 and +1. I change the order of -1 and +1. Okay. So now this will give me in, now this will give me in what? Descending order. So first Alice, then Tom, then Virat, then Rishabh, right? But then it will give me for all of them. Should have been compared by roll number. What will be compared by? Percentage descending, right? Should be compared by name, but will be compared by percentage descending. So percentage descending means Alice, Tom, Rishabh, Virat. Alice, Tom, Virat, and Rishabh. Yeah. Okay. Now, isn't this there's some loophole over here? Shouldn't each of the list have their own separate comparison mechanism? So if I use comparable, if I use comparable, it gets added to the class, and we can override only with only one logic, right? Yes or no? But if I want all the three separate logics also to work in parallel, then I can use comparator. Then I can use what? Then I can use comparator. Then I have to make three separate comparators. So first comparison was using which style? Compared by roll number, right? So I will make roll number comparator. So make a new class called as comparator. Okay? Roll number comparator. And a class implements the interface, right? The implement is comparator interface. Which is interface? It is from util package. Comparable was from which package? Java.lang. Okay, so if I go to the student and if I hover on this control and hover on it, it goes to the package. Which package is this from? Compare. They both are in util. It, no, it's in the java.lang. It is importing. It is importing java.util. It is in which package? Java. So comparable is in java.lang and comparator is in now. We are going to compare objects of which class? Student class. And now why is it showing a red line over here? Because whenever an interface implements is implemented, that class has to override all the abstract methods, right? So in this, there is only one single abstract method called compare. Only one single abstract method is a compare. Okay. So I'm comparing student one and I'm comparing student two on which parameter? Roll number, right? So I'll take the logic of the roll number from here. Roll number comparison logic is there, right, over here, correct? I take that and put it over here. So here I had this, but here I have S1 and S2. So I will say what? If S1 dot roll number is greater than S2 dot roll number. And then if, and okay, can I access direct roll number over here outside the class, right? So get roll number. So and now again get roll number and get roll number. Okay. So now whenever I'll make the attendance list or the student attendance will make. I wanted roll number is was for what? This one, right? So now I will pass the object of that comparator. New roll number comparator. So this will use this comparison logic to compare. Okay. So will be compared by roll number. Now I want the exam hall that I want compare by name, right? So what will I do? I'll make a new class, name comparator, and implement comparator. And which class object will be compare? Student, and add them. So I have now two student object over here, S1 and S2, and the string has a function called as compare to, right? So what will I do? S1 dot get name dot compare to S2 dot get S name. That's okay. So now I've got the function. Now I'll use which name comparator. So I will come here and say what? Let's not fidget. Let's not fidget with this. Let's make a new one then, so that we all have all the versions available. Okay, so demo 4 I am coming. This I want using new roll number comparator. This I want new name comparator. And for the exam hall, I want it using, and for the student rank, I want using percentage comparator. Okay, so implements what? Comparator, comparing objects of student class, and add the function compare. Take the logic of the percentage, right? Where is it? This one, right? Take this logic and put it over here in the percentage comparator. But here now O1 is S1 and O2 is S2. So what will I say? Instead of this, I will get S1 dot get percent, because I'm outside the class. Get percent dot S2 dot get percent. Okay, and then S1 dot get percent and S2 dot get percent. Okay, now I can come here in my student class, and I can comment out this. No need for any implement, no need to implement any comparable. Okay, and I can comment all this. Now I have three separate comparison mechanisms. Okay, now this again my class is a Pojo class, simple class, and now if I come here, I want to add them using what new. Okay, now let's add them and let's run them. How the output became same. Yes, roll number. Yes, S2. Okay, yes. Oh, let's come here now again and let's run. So now you see roll number comparator 1, 14, 17, 18. Then name comparator Alice, Rishabh, Tom, Virat, and percentage 88.5, 87.5, 78.5, and 77.5. Getting all three working fine. Comparator comparable done. Understood. Three set now.